No, I did exactly.
Okay. What I'm presenting here is the very early stage of a work in progress. I'm halfway through my master's degree and haven't started a thesis. I will read the paper and then quickly explain my interpretation in a series of diagrams. My aim is to establish a connection between Charles Peirce's diagrammatic logic and Badiou's philosophy. You may be aware of Badiou's diagrams. They appear throughout his philosophy, at least from theory of the subject to logic's world. But you may not be aware of diagrammatic reasoning itself, of which Peirce is to this day the greatest exponent. The paper presents important features of diagrammatic logic of Peirce's system of existential graphs, which by his own estimates was the most important of his many contributions to logic. Then in a series of diagrams I present an interpretation of one of the two complex typologies of classes of signs considered important by Peircean semioticians. This one is classified, that I'll interpret, is a classification of 10 classes of signs. The so far uninterpreted, the other so far uninterpreted typology is for 66 classes. From my interpretation, we will see an equivalence between Peirce's typology for 10 classes of signs and two diagrams, with the diagrams by Badiou at the end of meditation 8 in being out of M. They were found, where they are found in, that's the two diagrams, so, anyway, that's the, so, I'll go back to the diagram. Right, so Peirce had already made significant contributions to the development of modern logic before developing his systems of graphical logic in the 1890s until the end of his life in 1914. He says he had always thought with diagrams, and he's certainly been experimenting with them since his days teaching logic at Johns Hopkins University in the early 1880s. There he had the good fortune to be associated with James Sylvester, who with William Clifford had been researching the use of chemical diagrams to map algebraic invariants. Peirce's work with diagrams was a continuation of his work with algebra. He was always on the lookout for better tools to develop with which to develop his logic. As early as 1883, Peirce's student Owen Mitchell had stated that necessary reasoning, quote, can always be reached by adding to stated antecedents and subtracting from stated consequence, end quote. We will now look at what this means in Peirce's system of existential graphs. As early as 1882, Peirce had begun modelling logical operations using diagrams based on chemical graphs. In 1892, he says, quote, to one skeleton set, another is added to form a compound set. Then the first perhaps is dropped, and the ideas which remain are viewed in a new light. End quote. For Peirce, all reason involves insertions, omissions, and viewing things in a new light. With them, Peirce claimed he was able to reproduce the very, quote, motions of reasoning, and, quote, the operation of thinking in actu, end quote. In fact, he says, the system, another quote, the system of existential graphs is a rough and generalized diagram of the mind, end quote. Not the thought process, as it takes place in the mind, but the argument formulated after the fact as a summing up of the thinking process. The system of existential graphs is divided into three parts: alpha, beta, and gamma. The major division reflected in the separation of the alpha and beta parts is between propositions whose form does not require the use of so-called lines of identity, and propositions whose form does require the use. The addition of a means to treat abstractions in the gamma part does not change this classification. For some terminology, Peirce's logic is a logic of relations. If the graph of a given proposition contains zero number of lines of identity, that proposition is non-relative or truth-functional proposition. If its graph contains one line, the proposition is categorical proposition, and if its graph contains more than one line, it's a relative proposition. Don't worry so much about this. Hopefully it can be clear. More terminology. A rimmer is like a chemical atom or radical. It is a proposition with a noun removed from it. The heavy dot or dash used to represent the blank, so you've got an English phrase in the blank where the noun was removed, may be filled by a proper name. Extending the analogy, the chemical analogy that is, multivalent remata are known as polyads. Then there's also the monad with a valency of one, and the medad with no blank. In the system of existential graphs, it is not possible to express a formula with three individual variables, which means that every heavy line or blank, heavily drawn line blank, must be able to be filled again by Peirce's self-described remarkable theory states that every polyad higher than a triad can be analysed into triads, though not every triad can be analysed into dyads. This is significant because you may think that two dyads could be joined to form a triad like this. And so you've got one dyad, those are two with two lines like with two blanks, and that point in the middle. Okay, so this is significant because you may think that this can happen, that you can join two dyads to form a triad, which the theorem so this depends upon the existence at the arrow in the diagram of a point of Ter identity, a triad, without which there could be no such join. According to Peirce, such a point is required. I quote, Ter identity is not mere identity, it is identity and identity. But this "and" is a distinct concept, and precisely that of Ter identity. Next, is the composition of concepts. Continuing a chemical analogy again, the components, I quote Peirce, supply each other's lack. And, I quote, each component must be indeterminate in some respect or another, and in their composition, each determines the other. There is no cement which unites two or more concepts together. Rather, they fit together like the pieces of a jigsaw puzzle, or mesh together like teeth on gears. Yet no concept becomes so determinate that it cannot be made more determinate, since it's always possible to increase knowledge. As for the graphical notation, no such special symbol is required to indicate the grouping of expressions. The cut does group expressions, but it also expresses negation and indicates quantification. It's very economical and powerful notation. The system of existential graphs, in fact, requires only two special symbols, the cut and the line of identity, plus the sheep of assertion. Graphical operations, which I can only mention, adding or removing the double cut, writing any proposition on an oddly enclosed area, erasing any proposition from an evenly enclosed area, extending the line of identity inward through cuts, all can be performed quickly and easily using this notation, which is why Peirce rated it so high. The system has two axioms. The first is that the sheet of assertion itself be considered a graph. The sheet just being what you scribe on. This allows Peirce to graph the conditional propositional material implication if P then Q without asserting either P or Q. For this purpose, Peirce invented the scroll, a self-returning thin line comprising two lines or ovals, one placed one placed on the other. One placed on the area enclosed by the other. Each cut is interpreted as cutting the surface of the sheet of assertion so as to separate what lies inside the cut from the surface of the sheet. And I think really a kind of colloquial way of saying it would be that I think that this represents a depth going back into the sheet. A self-returning thin line comprising two lines or ovals, one place. Each cut is interpreted as the conditional de ines, which is, I guess, it's those words mean to do with essence, contingencies, remember. May thus be expressed without asserting either P or Q by placing them on the sheet. The second axiom is that the unattached line of identity, or heavy dot, mentioned earlier, the sheet of assertion represents the universal discourse for all the objects to be talked about. The heavy dot denotes the existence of a single individual, but otherwise undesignated object in the universe represented by the sheet. To explain, the line of identity, which is the axiom which is the axiom introduced in the beta part and which distinguishes it from the alpha part of the systemic graph system, asserts that if two different somethings are the same, they must be joined. The line of identity is a graph asserting the numerical identity of the individuals denoted by its two extremities and can be represented with a heavy dot. The following graph means that there is a black bird which is mischievous. We could consider the heavy lines as a single line of identity with three extremities, but Peirce usually preferred to consider the diagram as three lines of identity which have a point in common, namely the point marked with the arrow. He called the totality of all the lines of identity that join one another a ligature. As mentioned earlier, the point in the above graph from which these three lines of identity can be taken to proceed has the force of the conjunction and. I use that word force quite deliberately. Hence, the graph could be read, there is something which is a bird and is black and is mischievous. When a line of identity crosses a cut, there is in a sense two lines of identity, one outside the cut and one inside the cut. These two lines have a common point in common, the point on the cut, so that they form a ligature, and hence must be taken to denote the same individual. So this graph means something exists, something exists and is false, something exists and is false, and it is false that this same something is ugly. That is, something is not ugly. So that's basically. The line means it's something because it's not enclosed itself. rather than everything if it's enclosed. And the circle that you see is a sign for negation, so it means something is not ugly.
Is there a cut? What's a cut?
Well, the cut belongs to the scroll, which is what cuts the. Yes, it is. It is the graph earlier. This one here, this scroll. It is. As I come to you read inward from the least enclosed to the more enclosed. So this is singly enclosed and doubly enclosed. So you go not P, because that's a negation. It's cutting, it's not written on the sheet of assertion, which if it were, it would be being asserted. It would be so this, and then you read further in, and it goes not Q. So which is equivalent to if P then Q. So okay, so cut this to pieces to try to cut. Anyways, when a line of identity lies on the sheet of assertion, it represents some individual object. And when it is once enclosed, it represents every individual in the universe represented by the sheet. So that's what I was saying before. If that one had been closed by a second circle, it would have represented not just something, it would have represented everything. So, you're going back to the two quantifiers that so which is a Persian idea. I mean, got it a couple of years after Frege, it was Persian that everybody picked it up from.
Right.
Yeah, so when a line of identity lies, blah, 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 when only part of the line of identity lies on the sheet of assertion, it's interpreted to be as enclosed as the least enclosed or outermost part. If that part is on the sheet, it denotes something suitably chosen. If its outermost part is once enclosed, it denotes anything you please. In logic systems generally, a symbol which denotes a suitably chosen individual, an existing individual, is called an existential quantifier. A symbol which refers to any individual at all, taken arbitrarily from the universal discourse, is called a universal quantifier. An unenclosed or evenly enclosed line, then, is an existential quantifier, and an oddly enclosed line is a universal quantifier. This supposes the line of identity is read before the cut, which encloses it. It will become clearer when I get to my interpretation of his typology, and I will have to go into the question time. I'm sorry. Try to get through as quick as I can. We will interpret a graph. We read when we interpret a graph. We read the graph from the outside, or least enclosed part, and we're proceeding inwards. Method first called endopoietic. A nest, he says, sucks the meaning from without inwards unto its centre. So first, all unenclosed lines are read, and then those that are once enclosed, and then those that are twice enclosed, and so on. Okay, so according to Peirce, a good system of diagrams should be iconic. That is, the parts of the diagrams should be related to each other in the same way that the objects represented by those parts are themselves related to each other. And that again will become clearer when we get to the interpretation. The utility of diagrammatic reasoning is its capacity to reveal unexpected truth. And this capacity is a peculiarity of icons. A great distinguishing property of the icon, Peirce says, is that it that by the direct observation of it, other truths concerning its object can be discovered from those which suffice to determine its construction. And this is the basis of Peirce's realism. So you infer what is below the sheet, if you like, or which is not visible from what is visible. So I now turn to you bring what's below, if you like. We make it so that if something were brought from below, it's consistent with what you see. So at least that's how I interpret it. I now turn to Peirce's typology of science, which I will briefly attempt to interpret in accordance with the conventions and rules Peirce laid down for the construction and interpretation of existential graphs. Alpha and beta, the alpha and beta parts, have 5 rules, basically the same rules, for the transformation of one graph into another. For erasure, insertion, iteration, deiteration, and the double cut, which is just the two circles of nothing, and you can be added or taken away, which I'm not convinced, but it's great. Right, now this is what I'm going to be interpreting. You'll recognise some of the terms. Icon, you'll recognise symbolic, you'll recognise an index, you'll recognise, because that's the most well-known fundamental class of sign that Peirce uses. But there are lots of them. 66. Anyways, and this is 10. So, an adequate interpretation of this typology, as far as I'm aware, has not been provided. Yet the interpretation of it, an even more complex, and the even more complex typology of 66 signs, classes of signs, are considered by leading Peircean scholars to be, quote, the most pressing problem for Peircean semioticians, according to one. This version is equivalent. No, this version is equivalent to the first version. Suffice to say, the specific numbers relate to the adicity. So you know you've got monadicity, diadicity, and triadic, right? So you've got these. That's what adicity. It's just the valence, if you like, of the relation, and the relative position of the numbers in each triad. So you've got, it's made up of triad. You've got this triad, the triads. And you've got another triad, larger triad. 3 of them, an odd one in the middle, and then the thing. So and there are three different numbers, 1, 2, and 3, representing. Sorry, a bit. Representing the valence. So, and you also notice, and I thought this was the first thing that struck me when I looked at this, is that there's a deliberate positioning of these in the triad, and this one number is more prominent than the other, so it's obvious. Trying to the position is and it relates to Peirce's 3 categories of firstness, secondness, and thirdness. So my interpretation proceeds as follows. Starting from the outside and progressing inwards, we can trace a series of paths. Now, this is going to look pretty crazy, but it works. We start with a particular state of affairs, or index. All right, it's not bad. So you started at 1 there, just a suitably chosen existential quantum. It's not enclosed, so it's a definition. We start with that, or index, as it's called, and I've got written here applied universal quantified to that is, we start with a suitably chosen individual and proceed to a symbol, which is what I enclosed in that circle, whatever you call it, which refers to any individual at all. So I guess it refers to any in the universe on the sheet. We don't actually haven't defined the sheet yet, so at the moment it's just those lines, these position numbers that form that we're talking about. So so it refers to any individual at all taken arbitrarily from the universal discourse or universal. And evenly enclosed. So we just continue to basically just. Well, look, it's as in one of the earlier talks. This is quite a repetitive process. You can where that disappeared to my life. But anyway, so I'm basically repeating the same process, except where we ended on that symbol is now considered to be an icon. And again, I think that there is a depth aspect. I've kind of shadowed in another cut below that too much. But I'm not going to try to confuse things even further. So we start with the icon, follow through, we trace this path through these objects. Again, I'm going to just. But anyways, so I've done that as well as I can through all of those, and we find this triad of twos where we finish off. That's the universal quantifier. That's simple. So. I just do that again, basically. It looks messy, but I just do that again. But here, it's interesting, because what I've done is I've used one of the rules. I've inserted a... no, I haven't. Basically, I've created a scroll there, really. That's just a kind of... that's an if-then structure. But, and I continue again. Now we come to, I apply this rule of transformation, rule of erasure, or subtraction. Any evenly enclosed graph, blah blah blah, of a line of identity may be erased. Okay, so these are all lines of identity. You've got, it was crazy, couldn't make it look normal. But basically it's just following the same process. But what happened is, when we did get to the larger symbol, this entire symbol, and define a universe, all of the objects that we're dealing with, then what was enclosed here became we can because it's now. What was enclosed there was itself doubly enclosed with this and this. I could erase that. That's what the rule says. I can take that out. So I do that. And then I continue again, going around. This actually does make sense. I'll put the graphs up. I'll send them to anyone if they want. And I noted that odd circle in the middle, which was, it's a triad, but it's not like these. Well, that's our symbol we end up with on this permutation. So, right, so, and we're a bit stuck when we get to there. Yeah, when we get to there. There's really nowhere to go. So, no, I don't. I'm getting to the crux of it. How long have I got? Have I overshot?
Well, I mean, if you
Oh, right. Can I subtract.
We've got
Can I make
the
that?
threat of being locked in by the security.
It's really important that I get
Yeah,
to
yeah, no, I understand.
a short bit more. Otherwise, it's going to sound crazy. I've only got like a few lines. Okay, so we're forced, literally forced to continue. We're forced to continue. Can't continue like the quote from Beckett. I must continue. So I invent this path from which I can recommence this process, which I do. Sorry, just lost my place. That's all. Okay, so I'll just flick through these. Basically, what happens is it looks like this diagram. You've got that dark dot, which is another way that the line of identity can be, or heavy dot, another way that the line of identity can be represented. So and what you have is an individual formed through this process. It's a major problem for it's a major individuality is a major problem for logicians, and this is the first solver. So then you have this is magic, but that's the first solver. I think that you use pictograms is very much a diagrammatic thinker in my view, and this as well as being the first letter on our sheet of assertion, literally the first letter, alpha, it also represents one. Sigma is just one circle. The beta is two circles. And even this is very similar to where I introduced the ligature, which is where you've got these three aspects on top of each other. Here, in inclusion, again, we've got two. And probably with the equal sign. I'm not sure how that relates to mathematics equals ontology, but that would be something that. The next thing is I go from this point, which is the first graph in the column, mathematics column, on the what do you call it? Sorry. I'll go on. So I will just repeat this process. Basically, what it would have allowed me to show you is the other rule of insertion, which is here we've inserted those into those other parts. It's just a reverse here. And then as we've gone around again, they've been erased. So what we end up is building up this layer, I think. This layering, and actually this is an icon because it has actually the same structure as that. You could fit that in there. Well, that is where that would go. And that's what an icon is. An icon is, as I could repeat, is the whole has the structure of the pipe. So you've got it displays the structure of the pipe, and that's how the whole thing works. So I think that's really interesting, and because it's iconic, it's a good formalism, according to Perth. So that's why sorry, go ahead.
We talk about the French philosophy of concept, or the French philosophy of mathematics, and try to show that it is in a way not maybe essential, but very useful in order to. It was historically very useful to bring about the mathematical meta-ontology, which Badiou constructs in Looking and Tive. So I'm just I'm gonna talk about first what to me is the basic novelty of this kind of meta-ontology that Badiou proposes. And then I'm going to show that that there are some predecessors working towards, even though not explicitly, they're working towards some kind of meta-ontology. So I was going to talk about Brunswick, Cavaillés, Lacan, and de Santi, but I think I will leave Lacan and de Santi because it will be too long. And anyway, they are more well known. So I think it would be less interesting. So in the preface to his Being and Event, Alain Badiou describes how in the mid-1980s he came to the conclusion that mathematics writes that which of being itself is pronounceable in the field of a pure theory of the multiple, thus being the science of being by being, or ontology according to the classical definition. His thesis is presented as a way of escaping the alternative between Aristotelian empiricism, according to which mathematics abstracts its ideas from the world of object, and formalism, according to which the only criteria of validity of mathematics is the internal coherence of its construction. This remark of these suffices to show that Badiou's ontology is not the traditional theory of the general characteristics of common to all beings, and mathematics according to ontology. Empiricism could easily qualify as a contribution to such an ontology. Mathematics on Badiou's account is an ontology in the post-Heideggerian sense, where being itself is clearly differentiated from what is presented in the form of individuated objects. Being as theorized in mathematics would not be this or that particular thing or the common features, but the movement by which those things come to exist in a particular situation. Mathematics, by virtue of its capacity to subtract itself from any particular situation, what we recognize as its abstract nature, can formalize the way being what is presents itself in any given situation. Mathematics, or ontology, is thus the presentation of presentation, thus close we can come to that which is presented in presentation being, or being. This means that in a certain way, in opposed to Badiou's presentation of his work in Manifesto for Philosophy as a return to Plato, Badiou does not return from the path of the critical limitation of philosophy's scope. Being, as Kant puts it, in itself is still foreclosed from human reason. Okay, that's just my... I know this interpretation is controversial, but it's essential to my argument. So I can try to justify it later on if you like. This is manifest in Badiou's refusal of traditional critical interpretation of mathematics, such as the Pythagorean idea of being as an anchor, or Plato's similar idea of a tetradic structure of being. Being in itself is not directly accessible to mathematical thought, its only access is to what is expressible of being. The question then is, what is new in Badiou's discovery about the essence of mathematical discourse? What sets it fundamental from critical philosophy, for which mathematics also could express it? What is expressible of any object, or to put it in a more familiar term, what can be known of the transcendental conditions of any experience? My hypothesis in this paper is that specific features of Badiou's conception of mathematics can be better grasped by concentrating not on its explicit thesis on mathematics, but on the way in which he relates and the way in which he does not relate to scientific discourse. What is important in his idea, according to which mathematics is a presentation of what can be expressed of being, and that philosophy is, amongst other things, the meta-ontological interpretation of mathematics, according to that insight, is that philosophy no longer confers upon mathematics its laws and force of its own immediate access to being by being. To put more simply, what is important in teaching, according to which mathematics is ontology, is that it entails that philosophy is not ontology. But this transformation of philosophy in its relation to mathematics does not depend uniquely on Badiou's discovery or decision in the mid-1980s. It is also the culmination of the French tradition of philosophy of mathematics and science that waits a little attention. It is my aim in this present paper to introduce the main thinkers, or two of the main thinkers, Leon Brunswick and Jean Cavaillés, and demonstrate their relevance to Badiou's methodology. I will will show that this thinker contributes to the destruction of epistemology, thereby clearing the ground for Badiou's very unepistemological approach towards mathematics. So the philosophy of Leon Brunswick is a good place to start, for in a way it can be situated in between two traditions. The critical philosophy dominating the 19th century and the philosophy of the concept of the 20th century, as Badiou himself has remarked in a recent piece on French philosophy in the 20th century. Brunswick was very enthusiastic about Kant's philosophical revolution and described it as the moment in which philosophy took its definite form, whereas classical philosophy tries to ground philosophical ideas in an objective structure, so Brunswick's argument goes. Kant realizes his revolution by returning the case towards the structure of the mind in order to find a ground for his claims. What he, however, reproaches Kant for is not having gone far enough in his break from the metaphysical tradition, since he only transposed the Aristotelian categories from being to mind, thereby maintaining those categories as the ultimate horizon of our experience. In his mind doctoral thesis defended in 1887, La partie métaphysique du syllogisme sur le narrateur, Brunswick attempts to show how Aristotle's ontological categories are no more than the translation of his syllogistic method in biology into the structure of being, and have no more validity than their effectiveness to produce knowledge in this field, which incidentally Brunswick shows is very little. In his major thesis on modalité du jugement, he tries to, in a like manner, to derive those concepts that Kant treats as the conditions of judgment from previous judgment, thereby applying Kant's critical method to undermine the foundations of his own theory. Brunswick admits that the concepts are the conditions for judgment that relate to predicates substances. The judgment table is blue depends solely on the availability of the concepts table and blue, but those concepts that constitute the material of a particular judgment are themselves the result of another previous judgment, where all the instances falling under the concepts are unified. The concept blue is the result of the unification of diverse experiences of the color blue, and the same applies to every concept that can be used as the basis of a judgment, including such categories as substance and causality, which can posits as the conditions of any judgment. They also must have been previously in another judgment. So, against Kant, but at the same time in a more profound fidelity to him, Brunswick calls for a return to Spinoza, where he finds a theory of mind that goes beyond the limiting structure of Kant's mind. In Brunswick's reading of Spinoza, the attribute of thought is different from the attribute of extension, in that the former is able to transgress the limits imposed on the latter. The essence of thought, spirit, and Brunswick's jargon is therefore its unifying power, or the movement beyond material boundaries. What Brunswick gets from Spinoza as well is what he calls the Spinoza's conception of truth, where the latter is not primarily a correspondence between a subject and an object, but a kind of an objective force. The action of transgression of human boundaries imminently creates its own criteria. So, as an objective force, truth cannot be assessed immediately in the mind's self-reflection, but only from the outside of any other object. In order to assess truth, we can only look at the objective results of spirit's creation. His seminal work, Les Étapes de la philosophie mathématique from 1912, can be understood along these lines as an attempt to approach spirit through its mathematical creations, but also as a critique of philosophy's tendency throughout its entire history to elevate the particular creation of mathematics into a fundamental ontological structure or a number of self-evident principles that can be used to deduce the rest of mathematics by a theoretical construction. He again criticizes Kant for his time for making the fragile synthesis of Newtonian science into the eternal structure of the transcendental subject. The invalidity of Kant's hypothesizing of science's results becomes all too apparent by mathematics' subsequent development, for instance by the invention of non-Euclidean geometry, making the customary three-dimensional space into one possibility amongst others, and not the sole structure by which being can be revealed to us, or the invention of non-Aristotelian logic, which similarly relativizes the formally self-evident principles of human thought as it relates to truth. He then, after criticizing the major currents in the philosophy of mathematics, extracts from the history of mathematics a concept of truth inspired by both Kant and Spinoza. by Kant because he considers truth as a synthetic activity, but also because he makes for truth a historical creation creates its own criteria. An example of an elementary mathematical truth is the creation of a means of comparison between the two quantities of good in trading that by contraction arrives to abstract from that activity the concept of equality and the procedure of verification of the equality of two quantities by taking one element of each group at a time and to verify whether both groups can be exhausted in this way. Brunswick then uses this concept of mathematical truth against the other currents in philosophy of mathematics to show that truth is not an extra mathematical reality that philosophers can find, and uses a means to independently evaluate mathematics because truth is already first inherent to mathematics, what is required of the philosopher understood as the one who attains to truth is the study of the historical creations of mathematics, so should be better equipped to defend those creations when they emerge within his own historical moment. In this way, Brunswick is at the foundations of a current in the French philosophy, the philosophy of concept. Beyond apparent difference between Brunswick's criticism and Badiou's ontologism, they share the separate ordination of philosophy to mathematics as a source of creation. Moreover, the way Brunswick's philosophy relates to mathematics bears striking similarities to Badiou's way of relating to mathematics. They both try to extract from mathematics the concept of truth instead as a source of universality by which the human animal can surpass its isolation. They both say truth as an objective force that separates itself from the particular situation in which it emerges. For both of them, truth is an internal value and an infinite possibility in virtue of its universal applicability. I will now verify whether the same applies to one of Brunswick's disciples, Schoenkamp. Although not add much to his mentor's positive theory of truth, undoubtedly because of the sudden interruption of his work as he was executed by the Nazis only 40 years old, whilst participating in the French resistance, Tryggvi did manage to contribute considerably to the discussion of epistemology. His main problem was that of the foundations of mathematics, what validates its tenets and operations. In his principal thesis, Methodaxiomatiki of Humanism, he studied and criticized theories emerging within mathematics to found itself what mathematicians called metamathematics. He criticized classical intuitionism and logicism and studied in detail David Hilbert's axiomatic formalism. Tryggvi refused intuitionism, the theory according to which a mathematical claim was improved by constructing its object completely and testing the lattice coherence because it does not manage to explain mathematics' ability to go beyond what was previously imaginable, since by principle it excludes any surprises in the mathematical construction. Logicism, or the theory that evaluates a mathematical theory by the conformity of its structure to logical principles, was insufficient to him because it cannot justify those principles. They are simply extracted from mathematical activity at some moment of its history. Hilbert's axiomatic method seemed to him more promising. The method was developed as an attempt to evaluate mathematical theory by formalizing its foundations completely as a set of action and to measure the force by verifying whether a given statement could be demonstrated or refuted within it, or whether there was need to add more actions. As purely formalistic, the validity of the axiomatic was determined merely by the internal consistency of deducible statements. But in order to determine the consistency of all of deducible propositions, the axiomatic should allow the completeness of the field of statements. It has to determine whether any given statement was either deducible or refutable. Gödel's incompleteness theorem put an end to that ambition by showing that for every axiomatic that includes elementary arithmetic, you always end up with some undecidable statements that could neither be demonstrated nor refuted. In the end, Hilbert, like the logicists, was guilty of trying to found mathematics on a hypothetical deductive method, one of the research of mathematics without attempting to follow the way in which the axiomatic systems were formalized were engendered in the first place. His final and most famous work, Geologie de la Théorie addressed the problem of foundations within the philosophical field. Such philosophers as Kant and Rudolf Carnap were criticized for not being able to explain the genesis and the productivity of mathematics. According to Kavai's analysis, in order to found mathematics, they assigned to themselves the task of emptying out of it everything empirical until they were left with an empty and formal structure wherein afterwards empirical facts could be inserted. But the formal structure that resulted was unaccounted for, as in the foundational work of the mathematicians discussed in Method Axiomatique. Kant and Carnap treat the result of mathematics as its foundation. So Kavai's looked to phenomenology of the phenomenology of Edmund Husserl's and Husserl's attempt to found mathematics. Like the other ones he has studied, accounted for the genesis of formal structure by the intentionality of scientific consciousness. That is the elementary fact of consciousness, that it is the consciousness of something. Likewise, mathematical structures must be explained by the fact that they are structures of something. Unfortunately, Husserl covers up this intentionality by the original unity of consciousness and its object in a transcendental consciousness. If mathematics ultimately founded and structures and operations founded by such an original unity, then we cannot understand how new knowledge comes to be otherwise than as the reactivation of a forgotten old meaning, which was not satisfactory for Kavai, since there is no reason in particular to validate the science by the original experience that created. As an alternative to Husserl's philosophy of consciousness, Kavai then outlined the philosophy of the concept inspired in part by Hilfert's work and the importance of the mathematical design. He understood mathematics as a process whose fecundity depends on the opacity of its material, the science. The opacity depends on the fact that the signs are not presented to the mathematician in their reducible meaninglessness, but are traces of the mathematical act that created them. He names in his book two general ways by which mathematics can develop the virtuality of the signs. Firstly, it progresses when its scope is extended and its material formalized by the use of paradigms. For instance, when along with numbers, mathematicians start to use variables which preserve some of the rules that apply to numbers. Secondly, it progresses due to the thematization of its operations. For instance, when the mathematician determines the operation of addition by the categories of associativity and commutativity and another theory superposed onto the older one. Mathematics is thus necessary in a negative sense insofar as its progress is not owing to the contingency of the mathematician's consciousness, but only to the inherent qualities of the science he works upon and that he can either discover or overlook. In this fashion, Kavai tried to liberate mathematics from any spiritual reality which could be independently discovered by the philosopher, as in Husserl's philosophy of the consciousness. Mathematics should be a process capable of producing its own norm, as in the Spinoza's conception of truth gets out by construct, but also capable of surprising discoveries due to the opacity of its material. The philosopher is not able to measure it against her own concept of truth, but only hope to learn from it from the inside. Kavai contributes to the undermining of a certain figure of the epistemologist, the one who evaluates science's knowledge claim according to her own norms. So I'll jump to my conclusion, which is yours. These four philosophers, Brunswick, Kavai, Lacan, and Dusonti, thus all contribute to the destruction of a certain subordination of mathematics to philosophy. I would like to insist that this destruction of mathematics can also be understood as a defense of mathematics universality. All four defend mathematics universality against different currents within philosophy that try to particularize mathematics and subordinate it to some heterogeneous knowledge or experience. Brunswick first does so by constructing a theory of truth as a spiritual force, transgressing material boundaries, and defends its unifying and universalizing power against any philosophical attempt to classify mathematics at a certain moment in its history. Kavai does the same by producing a conception of science where it is dependent only on its own structures and can thus avoid any appeal to a transcendental consciousness which would guarantee mathematics value. Lacan's anti-philosophy also defends mathematics' universality, or in his own words, its complete transmissibility against any philosophical hermeneutic liable to corrupt this universality by relating mathematics to some external reality. presumptive, finally, defends mathematics universality by measuring its effects on any natural concept. It's by this defense of universality I claim that the four philosophers of mathematics paved the way for Badiou's ontology, for the major epistemological obstacle to the equation of mathematics and to ontology are the other philosophical currents which particularize mathematics by giving sense to it, by relating it to some sort of foundations which as a foundation should be closer to being qua being. It is ultimately mathematics universality and its independence from other realities that make it fit to formalize the way being presents itself in any reality. So.
Thank you very much. So yes, does anyone have any questions?
Very interesting. I think that's very interesting, and I think it's a very fertile field. Not least, of course, because what we're talking about is the école normale tradition, and Badiou is very respectful of and loyal to école normale traditions. Just a simple question. Universality was key in what you were saying. Cavaillés, of course, is a great hero. He was a great heroic figure in the école normale. And I don't know if you know, but Canguilhem writes a lovely little biography of Cavaillés after his death at the hands of the Gestapo. Just my question is simply, is the emphasis on universality, which you kept on repeating, do you think that might have something to do with the sense that the école normale invests in a kind of republican conception of mathematics, if you see what I mean? That there's something to do with a connection between mathematics and honouring the tradition of republican politics, which after all was very, very strong in the école normale with people like Hare, for example, and Jaurès.
Well, it's sure in the case of Brunswick that it's, he's a very republican thinker, and I'm sure that he would see some kind of analogy with this concept of truth in mathematics and his defense of the French Republic, as the spirit's unifying creation. So
right. And Cavaillés as well. Do you think it's true of him or not?
Yeah, I don't remember him talking explicitly about it, but
I didn't hear you mention Bourbaki, and I wondered why you didn't mention Bourbaki. Is there some way in which Bourbaki just doesn't figure for you in the argument?
Well,
I mean, that's a genuine question. I wouldn't have a clue.
the idea was to talk about philosophy of mathematics.
Oh, I see. Right. Yeah.
So, it wouldn't be I think it wouldn't have been interesting to talk about conditions within mathematics, because it's obviously just set theory that creates the auto reflection of mathematics within the mathematical field. I was trying to advance that there was within the philosophical field there was some people that worked towards making this equation more evident.
Thank you.
You said that that Brunswick criticized Kant, if I heard correctly, for making the fragile findings of Newtonian science into projecting them as eternal categories of human cognition, and he did that in 1912.
Well, earlier.
Right. Yeah. Was that, in the way that Brunswick presented that argument, was he one of the first to make that kind of critique of Kant? Was he the first to?
Well, I'm not sure.
Right.
There was anyone before it, but I think.
But he presented it as his critique, as his particular.
Yeah, it was a part of his thesis. So.
Right. When Brunswick, I was just interested in this point when you said he argues that truth is a concept internal to mathematics, right? The construction of the comparison between quantities or whatever. What's he arguing against? Like, what's the alternative?
Well, as I presented, it's the alternative that, as say for instance, maybe he didn't know Husserl's phenomenology, but the idea according to which well, he criticized, for instance, Brober's intuitionism, according to which it's that mathematics truth is already founded in something outside of mathematics activity. That's intuition and the constructibility, and so.
Right.
Or the Kantian idea, according to which it would be some, a priori, or some categories of the transcendental subject that would somehow produce truthfulness of mathematical theories.
Any other questions?
I mean, just a comment really, that was a great paper. I think you shouldn't take the lack of questions as an indication of lack of interest. I think what's really impressive about it is precisely something that Andrew and I have been talking about, which is where, now that there has been a sort of a cycle of people working peripherally around Badiou and a cycle of thinkers who have done some of the more impressive exegetical work on Badiou, where Badiou studies is going. And I think definitely one of the sites in which it really needs to direct itself is into questions like how do we subtract Badiou from the position of his own exceptionality, right? How do we understand Badiou as fitting? With all due respect, I think everybody in this room has really appreciated over the course of the last 2 days the kind of generosity of spirit, the generosity of thinking that he brings to encounters. But when you are reading his book, he's not great on the footnotes or on telling you where he's getting his ideas. So this kind of historical kind of work is really fundamental and important. So I just wanted to say that. It's not to say that the kinds of directions that everybody's taking aren't important directions, but I think it's worth each and every one of you taking a thought on how the new directions you're taking the work isn't necessarily continuing previous cycles of thinking about Badiou studies, that in fact we are thinking about Badiou potentially in a new way, and I think that's one of the really nice things about this conference. But that isn't to detract from your paper, which I think is
No, was there a question or?
No, there wasn't a question. I'm just asking.
No, sorry.
Okay, so the question, I think that's a great point to end on, actually. Thank you. So, yeah.